if you're here today, you must be curious on how AI is impacting secure code learning. Or the question is whether our developers are still learning about secure coding when coding with AI, when by coding. This presentation is, comes from a research that we do every year. We analyze patches provided on our platform when we do training, when we do workshop, when we do public workshops. And the results are interesting. And we do this research, we started doing this research in 2024. 2025, we will redo it in 2026 at the end of the year. Now, research studies shows that whatever is easy to look up, it's also easy to forget. So you can imagine when using AI, coding, copilots, Claude, whatever you choose in your IDE, saying next, next, approve, approve, I like it, I don't like it, discard. Well, makes it quite hard to remember what we did, especially if you do it at scale. And the same research study shows that we actually reduce spelling knowledge by 20, 30% if something is too easy. Right? If something is harder, then we remember it. For example, if we type words manually, if we code manually, then we remember what we did and we actually learn. But if we don't code it, if we don't type it, it's quite easy to forget. Now, we use AI for coding a lot. Right? We use AI to understand our code. But when it comes to fix vulnerability, we have a double-edged sword. Right? Because, yes, we can fix vulnerable code with AI. But what we will see in our study is that sometimes the patches leave the code unpatched, still vulnerable. And there are some studies coming from 2021 where 40% of the code that was generated in 2021 contained vulnerabilities, and that's normal because models were smaller, not as smart as today. In 2022, LLM became a little bit more reliable to patch vulnerabilities on code that we will generate synthetically, meaning that we will generate vulnerable code ourselves to test the LLM, and that will work, but on production code, it will be something different. In 2025, I would expect something different, but actually, LLMs still struggle to patch properly code. And when I say LLM, I don't mean agentic tools, like LLMs plus tools plus iteration, but just if you put vulnerable code in an LLM, then most probably you will have something missing in the patch. Now, aside from reliability of LLM being able to patch code, we are here. This talk is not about that, but this talk wants to answer this question. So, will the AI security code fixes help developers becoming better in secure coding? Will they get the knowledge they need to secure their code? In order to answer these questions, we analyze different type of data, like commits, diffs, time to provide a patch, time to commit code on the challenges. So, who am I? First of all, I'm Davide Cioccia. I come from Amsterdam. I'm the founder of The Codex. And at The Codex, we do two things. We do secure coding training for developers on the defensive side. So we teach developers how to code securely. And we do pen testing. And we focus on supply chain. Now, I'm also the chapter lead of the AI security engineer in the Netherlands, mostly in Amsterdam. And I've been around since 2013 in security. And I love paddle and tennis. So if you want to play a match in Lille, I will be at the Dutch pavilion. So come find me. Now, let me tell you a little bit how did we set up this experiment, how this research works. So what we do, whenever we do trainings, we do public workshops, and we organize workshops at conferences where we get a lot of submissions from different types of profile. The idea is very simple. We give attendees and students AppSec challenges, and each AppSec challenge is provided with security tests. So basically, an attendee needs to exploit and then fix the code to pass the challenge. And then we verify whether the patch is correct through automated security tests. For this experiment, we analyzed 420 patches that were submitted across 3 different complexity, like easy, medium, and hard, and across 3 different languages, like Python, Ruby, and Go. Just to give you an example, this is what we ran at FirstCon last year. We provided like different type of challenges, also from incident response and patching. The green one are the easy one, the orange one are the hard one, the blue one is the very easy one. And how we do it, we run it like a CTF, but we call it fix the flag. So the idea is not to exploit and find the flag, but is to fix and get the flag. Right? So what did we look at? We look at this data. First of all, we look at the difference between pass or fail. We looked at how fast an attendee could pass a challenge or fail a challenge. And this is a very important data because we see how many iterations they need to do to really patch properly the code. We looked at the number of commits. We looked at the nature of code changes, so whether they add, delete, or change lines in the challenge. And we looked at the minimum, maximum, and average amount of code diffs between the different submissions, the difference between each commit, and also the number of files that the user changed. Right? So these are all data that are very important when you vibe code or code with copilots. So about the results, right? I'm here to share the results. Of course, the data reveals very distant behavioral pattern between AI and human, as you can imagine. And the first one is this: is the size of the code diffs that we see in the patches. So you can see that the AI-generated code has very large code diffs. I guess you experience the same. And actually is like 3 to 4, sometimes 5 times larger than the code that the human will write. And this is because AI-generated code contains mostly examples of how vulnerabilities are patched in textbooks or online. So it provides a lot of comments, it provides a lot of error handling that doesn't really refer to the vulnerability, but of course it is good to add it. While human written code really focuses on patching the specific vulnerability. So we see many, much less commits, and the code that is injected or added or deleted is much smaller. The second information that we got from this analysis is, of course, on time between diffs. The time that the user, or the user in this case, spent to commit. And we see that, as is shown in the graph, basically, the commit time intervals were mostly under 5 minutes for AI, while you see in purple, while for humans, it's more common to spend 10, 20, 60, and maybe sometimes more than 1 hour to patch a vulnerability, because you need to understand the vulnerability, identify it, test whether everything works, and then submit. And if you don't know about the vulnerability, you need to learn about that vulnerability. With AI, it's quite simple. You copy, paste, you generate, submit, and maybe you pass the challenge. Now, I mean, this type of data is expected. Right? AI is much faster than human in producing code, reviewing code. But we wanted to understand something different, and there is something interesting here. So if we look at the average max commit size of AI fixes versus human fixes, we see that the average is, for AI, 161 lines versus human is 17 lines. So this is like 10 times larger than what a human will code. And again, different reasons, and I will show you an example why this is sometimes. The average commit per repos are 10 commits for AI, while we have 2 for humans. And this is actually a nice data, because we can see that for AI to patch correctly a vulnerability and pass the challenge, it needs to do 10 iterations, right? So it needs to code, fail, test, fail, test, fail, so iterate through the loop. While for a human, 2 commits sometimes is more than enough. So yes, AI is faster, maybe more expensive in this case. It takes more time. And the average lines per commit is, of course, 57 lines for AI and 10 lines for human. Now, we looked at we wanted to understand how many lines change and how many files change every time AI commits something on the challenge. And we see that for medium challenges, for example, the lines changed where 493 in the first case changed in 50 seconds. So that means we have 591 lines changed per minute. And if you look at the data, it's pretty much the same. And that means that AI codes at 10 lines per second, right, on average. But we know that from our experience, humans can review code, understanding the code at 100 lines per minute. And this rate is exceptionally fast. Right? A human cannot keep up or cannot even comprehend at the speed of AI what's happening in the code. So if humans review the code, it will take much longer, to do a proper review than AI will do. So just to give an example of the study and how we did it, if we look at a code review from a human perspective, so a person solving the challenge, we gave them a vulnerability, like integer overflow. It's a vulnerability in NumPy, in Django. And the vulnerable code looks like this. Now, we are not going to go deep in the code, but the idea is that in this lab, we use an integer C in Python that is used by NumPy that basically translates an integer from Python to C and is vulnerable to integer overflow. So if you submit a number big enough and you sum it up to a constant that we have there, you will get negative numbers because it will overflow. Now, this is the diff or the changes that a person produced to solve these challenges. So we can see that we have 2 files changed, 10 insertions, and 4 deletions. So pretty small, compact, and easy. And the changes were this. So before, what the person did, he fixed the threshold, added a try-catch block at the end just to handle any exception, and he checked whether the number was still positive. Easy enough. Now, if we look at a code review from AI Copilot or Claude, we don't know which one was used here. The Git history of this change looked like this. So basically, we had 6 iterations where we have in the first iteration a lot of addition, like 39 additions, 2 file change, 31 insertions, 12 deletions, till we go all the way to test 6, where we have 2 files changed, 4 insertions, and 9 deletions. So a lot of iteration to understand where the vulnerability is and how to fix it. And the funny thing is this. So these are the changes. So as I said, the vulnerability here is an integer overflow, right? So you need to patch how the calculation is done. But what the LLM did, well, first of all, started changing the bug from true to false, not really related to the vulnerability. Fixed the allowed hosts to local host, in this case. That also not related to the vulnerability. And it started adding security headers for the web application. So also not really related to the vulnerability. And you will say, okay, but why is that? Because, well, what we think it is that the prompt used by the user to fix the vulnerability was quite generic, was something like, hey, fix the vulnerability here. And of course, the LLM doesn't know which vulnerability. There are different issues, different security issues. It's going to target them all. But our labs are designed to fix specifically that issue. So if you know where the issue is and what to do, you can use a good prompt that will definitely work for you to fix the issue. It's not rocket science. But if your prompt is generic enough, then most probably you will get something like this in your code. It will start changing things that it shouldn't change. Yeah, these are the changes that the LLM did. It just rewrote and deleted some comments that we had in our challenge. But eventually what we see in this case is that the user had to revert back all the changes and then start all over again. Right? So this is the changes that the LLM made, reverted, and repeat. So we see that, I mean, there is some learning here. Right? There is the user struggled, tried to solve the challenges without even understanding what was in the challenge, but then had to revert back because he wasn't passing the security test. So we hope they definitely learn something. So what we see more and more, especially when we do workshop publicly, is that there is an over-reliance or passive consumption of what the copilots or the LLMs produce. Sometimes it's too easy to accept changing without using critical thinking and understanding what changed. If we don't have the right guardrails or context for the LLMs, then things might go quite wrong. Potentially, our code might look patched, but will still be vulnerable. And so we have some recommendation for both learners and code reviewers, whichever role you have. So, well, for learners, definitely and this is what we try to push in our training, is to allocate time to understand the generated code. So even if the code looks professional and nice and clean, then it may still be incorrect. You want to scrutinize the output to ensure it addresses the root cause of the issue, because as we saw, right, LLMs might change multiple things in multiple files, but that doesn't mean that that's the right fix for a vulnerability. The fix might be there, but things might have changed all over the place. And the number 4 is actually very important. Review your prompt carefully and make sure you have included all the necessary instruction. So in order to do that, you need to understand what you're going to do, what you're doing. Right? And that's very important. So that's why vibe coding goes wrong. Not because LLMs generate insecure code, but because we don't know how to instruct it to generate secure code. Yeah, use different LLMs to do cross reviews. As I said, humans and people will struggle to review code generated by AI. I mean, the amount of code it generates is insane at that speed. So we will need to do reviews using LLMs. So do reviews use cross LLMs, and never accept code that you don't fully understand. So for code reviewers, of course, implement automated checks in CI. We have some nice research and toolings nowadays. And one thing to monitor is commit diffs and time intervals. If you see a lot of commits, a lot of code being pushed in a very short time, most probably that code hasn't been reviewed or even understood. Right? So I would say regularly remind your team of the risks and the potential downside of AI reliance. So we have, with this, I mean, I conclude these talks, we have some resources for learners and learning about secure coding. We have courses online that we provide to companies and conferences. And one more thing, if you are interested in learning about this research, we actually have it published on our blog with more numbers, more data, and you can understand more on whether AI coding or vibe coding, how that impacts the learning experience of a developer. Thank you. If you have questions, happy to take them.
Déjà, merci pour cette présentation. Merci donc David Cioccia. Si vous avez des questions à poser.
So in French or in English, as you wish?
Let's try in English.
English? Okay, sure. So I am Ever Shortful for PICO, which would do also AI consulting. My question is, very interesting experiments, and my question would be, do you have in your test done a benchmark between different AI LLM to see what are the differences? And in your case, what is the best one or the worst one in the scenario of security? And is there any good practice or recommendation, either than just check everyone, obviously, but which is for you the best to do in this case?
Good question. So this experiment is done on the results. So we don't see which LLM was used for the changes or for publishing for solving the challenge. Of course, we see quite a lot of difference with the latest models, using latest models from Claude versus Codex 5.4. They produce much better results. I can't tell you which one is better, because we didn't really run up our challenges against that. It will be a very nice experiment to do, to repeat like every 2-3 months, because new models come out. And in terms of recommendation, so as we saw, right, the problem is not the LLM itself, as you can get very good results from LLM, but the problem is in how and the context you give to the LLM. And with context, I mean prompt, of course, but also documentation about your code. And documentation in your code should contain also the security guardrails and enough knowledge for the LLM to understand how the code works, right? To identify, for example, business logic vulnerabilities. Those are the LLMs actually quite excel right now. But in order to find those and fix those properly, they need to understand how the code works. So documentation is still important, although very underestimated. And if having those guardrails in place on how to address security, maybe they're coming from your security requirements, making that available for LLM, it will give you much more solid code in that case. Thank you.
Est-ce qu'on a une autre question? Another question?
Also in French.
Pas d'autres questions? Bah, écoutez, on peut vous remercier. Merci en tout cas pour cette présentation.
Merci à toi.
David Cioccia.
Thank you.
Merci à vous pour l'organisation d'Igodex.